Good morning, ladies and gentlemen. I am delighted to welcome you all to the SECNASP webinar. My name is Matsidiso Matabane, and I'll be hosting the session this morning. So today's webinar is an exciting opportunity for us to come together as a community and delve on the topic on climate change and biodiversity risks. And we have an esteemed expert in the field who will share his invaluable insights and his experiences with us. Once again, we'd like to thank you all for joining us today, and we hope that you will find this webinar not only informative and engaging, but also enjoyable as well. So let's make the most of this opportunity to not only learn, but also connect and inspire one another. Without further ado, I will ask our CEO, Dr. Nompumelelo Oboko, to do the welcome and purpose for us.
Thank you, Dr. Matabane. Ladies and gentlemen and esteemed participants, good morning. A warm welcome to the SECNASP organized webinar on climate change and biodiversity risks, African perspectives. We are honored to have you join us today as we take a deep dive into this very crucial topic that holds immense significance for our nation and the continent, but most importantly, the global community. And I'm pleased and excited to share that we have a remarkable turnout with over 1,000 participants who have confirmed their attendance today. This overwhelming response to our invite signifies the importance and urgency of the topic we're addressing today, and your presence and engagements are vital as we collectively seek insights and solutions to this crucial topic. Climate change, as we all know, remains one of the most pressing challenges of our time, and its impact on biodiversity is profound. Understanding that the African continent, with its rich biodiversity and unique ecosystems, and South Africa particularly holding the rank of being the third most biodiverse country worldwide, is not immune to the challenges posed by climate change. Therefore, the insights that will be shared by our invited speaker will contribute to our understanding of the interconnectedness of these challenges and inspire collaborative solutions that can drive positive change. With that, let me therefore take this opportunity and also extend great appreciation to our speaker and an expert who will be introduced in a few minutes. I also want to take and thank each and every one of you as participants for honoring our invitation to be part of this crucial conversation and for your commitment to the collective efforts in addressing climate change and biodiversity risks. Therefore, I thank you all for joining us, and I look forward to the presentation and the discussions that will unfold over the course of this webinar. Thank you once more for joining us, and do enjoy and participate fully. Over to you, Dr. Matabane. Thank you.
Thank you very much, Dr. Oboko, for the very warm welcome. And without wasting any further time, I will introduce our moderator for this important session, Dr. Desmond Musecho. So he is the SECNASP Council member who chairs the registration committee. He serves as the vice chairperson of the IAPASA board and is also a board member of the Council for the Built Environment. He has over 20 years of work experience in the environmental sector. I will then hand over to you, Professor Desmond, to introduce our speaker. Thank you.
Thank you so much, Dr. Matabane, for the opportunity. And thanks, colleagues. I see people are joining in, which is very encouraging. I would not want to waste too much of our time. We've got a very, very interesting topic today that we're dealing with. That is climate change and biodiversity risks, and specifically looking at the African perspectives. I think it's a very relevant topic, and for that, today we would be receiving this information from Prof. Guy Midley, whose profile I'm going to read out to you now. He is currently acting the director for the School of Climate Studies and the Center for Innovation Biology. He's also a distinguished professor at Stellenbosch University. He has worked on climate change risks to biodiversity since the 1980s. Previously A-rated in plant sciences, he has achieved a further NRF A rating in earth sciences. He's a recipient of the South African NSTF and Ecologic Awards, Royal Society of South Africa's Malloth Medal, and German Humboldt Research Award for lifetime scientific contributions. He is ranked by Thomson Reuters as highly cited and in the top 200 most influential climate change scientists globally. He has contributed to multiple international environmental assessments under the UN Framework Convention on Climate Change, a Convention on Biological Diversity and Intergovernmental Platform for Biodiversity and Ecosystems. He chaired South Africa's Global Change Science Committee in the 1990s and the year 2000, and has graduated many students now occupying senior government, consulting, and academic positions. Prof. Guy Midley, can I bring you to the floor? Thank you.
Thank you for that very kind set of introductions. And I'm delighted to be able to speak to you. I hope I'm perfectly audible. And I'm now going to share my screen, which I will do to the best of my ability. And I will start my presentation. Correct. I trust you can all see the first page there. Yeah, thanks for this fantastic opportunity to speak to a large audience at SACNASP. It's really great to get such a nice invitation and to give you some African perspectives on what is really a critical issue. So I'm going to start off with a very quick introduction to the current state of the climate, and then talk about biodiversity risks, which are not only direct threats to biodiversity from climate change itself, but also risks that flow from our responses to climate change. And I think it's very important to look at both of those things because they're both very important. So very quickly, I think we're all more than aware of the fundamental driver of climate change, the problems that we face, the discovery of coal and oil as fossil fuels back in the late 1700s, early 1800s, which led to significant emissions of carbon dioxide that had been safely stored below ground in these fossil fuel stores that are now being released back into the atmosphere and returning our atmosphere to a state that it once was several millions of years ago. And if we continue, possibly tens of millions of years ago, when the world looked very different. And for example, when there were no ice caps on the North and South Pole and sea levels were 100 meters higher, we clearly would struggle under those sorts of circumstances. So this is an existential crisis if we do not get it under control. And we are literally, as countries, playing a game of brinkmanship with the futures of our children and our grandchildren as we speak. I want to make one point very quickly, which I think is wildly underappreciated. And that is that the excess energy that we are worried about, which is the energy in the atmosphere, which is causing global warming and changing the climate, is a very small fraction of the additional energy that we have added to our biosphere from greenhouse gas emissions. So the graph on the left shows you how much additional energy has accumulated in our oceans. It's almost 90% of the additional energy because of fossil fuel emissions has actually been taken up in our oceans, causing warming of the oceans and expansion of the oceans and sea level rise. You can see there in the shallow waters, 0 to 700 meters depth, the vast majority sits. Then even further down to 2 kilometers in depth in the oceans, a large amount of energy sits. And even more than 2 kilometers deep, we have warmed our oceans. Without that, the atmosphere would have warmed an awful lot more. So our oceans have buffered us against these fossil fuel emissions. And the purple line at the bottom of that screen is how much is in the atmosphere. It's a very, very small amount. So for those of you who say climate change is irrelevant, it's a small amount, only a few degrees, you really need to understand what the science is telling us. The amount of energy in the oceans is massive, and it's equivalent to, I think, something like 25 billion atomic bombs since the 1800s. I'm speaking in roughly, I can't quite remember the exact number, but it's a scary number. It is a huge amount of energy. You can see a certain amount of energy has melted ice, that's in the gray color, and some has warmed up the land, which we see, for example, in borehole temperature records. So the point is, we are massively changing the energy status of our biosphere, and the atmosphere is just the tail of the dog. And this is causing a very significant shift in our oceans, which we're seeing now, this year. For the first time, we're starting to emerge beyond sort of natural variability. And you can see the surface temperatures of the ocean in 2023 is well above the natural variability and the human-caused warming, even well above 2022. So how long are our oceans going to continue buffering us, and why is this happening? We'll talk about that. But this signals a phase shift in the condition of the oceans, potentially. Part of what's happening is this is driving melting ice, particularly in the Arctic, on land glaciers, Greenland, but also in the Antarctic. And we're starting to now see the Antarctic minimum ice extent starting to drop as warmer waters melt these ice skirts around the Antarctic from the bottom. This will lead to sea level rise. And essentially, we are committed now to at least 0.5 meter to 70 centimeters of sea level rise, no matter what we do. So if you live on the coast, start planning. There's no excuse not to. Greenland, we can see another huge body of ice also is well above natural variability and even the recent shifts. And this could also raise sea levels. These threaten the biodiversity along coastal systems, but they also threaten human rural coastal settlements. But they also, they threaten biodiversity throughout the oceans, in the Southern Ocean and throughout the oceans. The warming also threatens coral reefs, of which we have coral reefs along the east coast of Africa. And very worryingly, one of the trends that we're starting to see now is the not only emissions of CO2, but emissions of methane, which is a powerful greenhouse gas, which is released by natural ecosystems, including vast peatlands in the Congo and Central Africa, which are increasingly being converted, drained, and turned into farming agricultural areas. And that it contains huge amounts of carbon in the form of methane, and also northern hemisphere systems which are melting and starting to release methane from their soils. And since the late 2010s, we're starting to see methane start rising again. And part of that is due to natural ecosystems starting to emit methane. So the biosphere, which is supported by biodiversity, appears to be turning somewhat against us. And that needs to be watched. And there's some very significant shifts that we would want to avoid, such as big shifts in the migration of water, the movement of energy in the oceans from the northern to southern hemisphere. I won't go into this in detail, but even these large systems are starting to show signs of changing. This year, we seem to have a very warm ocean. About 80% of the ocean is in a marine heat wave state. Oh, sorry, it's not that high. I think maybe it's 60%, is in a marine heat wave state. And that is going to have massive effects on biodiversity around the planet, on the oceans, particularly coral reefs, and along the eastern seaboard of Africa. You can see the heat pulse that is projected into the Indian Ocean and the Southern Ocean. Vast amounts of biodiversity in the marine biodiversity is at risk. What can we do about it? Well, it's not rocket science. Scientists have been saying this now since the 1980s. If we look at the fluxes of carbon from fossil fuels from the land and fluxes into the land and into the oceans, we can see that the vast majority, it comes from burning fossil fuels. And we seem hell-bent on adding our country's name to the list of countries bringing the Earth to the brink of catastrophe. At the same time, what does biodiversity do? Well, biodiversity helps in a couple of ways. The land sink, the sink of carbon, the absorption of CO2 onto the land is a very large number. It's about 25% of our emissions. So biodiversity and the land is preventing a much higher rate of CO2 increase, and we need to protect that. So biodiversity is important in that sense, absolutely critical. If we had to pay for that service, it would cost hundreds of billions of dollars a year. And then the oceans also take up CO2, although it does cause acidification of the oceans. Now, what we have the land sink under somewhat of our control because we farm the planet, and we can also make big changes there. But of course, we've got to make big changes in fossil fuels. We need to avoid further emissions. One of our biggest risks is that every time the world warms and we get an El Nino event, which we're in now, the terrestrial biosphere emits more CO2, so it accelerates warming. And you can see that every time there's an El Nino, the rate of CO2 growth, which is shown in this graph here, you can see it cycles up, and the CO2 rate goes up. So the natural biosphere, biodiversity starts to turn against us. What could happen to the climate in Africa relative to the rest of the world? Well, those top two graphs show you, if we continue down our short-sighted fossil fuel addicted path, we end up on the right-hand side of that graph with Central Africa, Central Southern Africa, Botswana, Namibia, parts of Zambia warming by more than 4 or 5 degrees by the end of the century. That's an appalling act of self-harm, which is completely avoidable. And that's in the top graphs. You can see the potential changes in rainfall along the bottom. And these are just model projections. We've seen what's happening in the Northern Hemisphere in China, which has been partially destroyed by cyclone Doksuri, and Canadian wildfires. All these sorts of things are going on as we speak. So there's no rule that says climate change has to be linear. It can move in steps as well. And why are we playing with these risks? What are the risks for Africa, including biodiversity? Well, these are not only future risks. This report, which is the African chapter of the IPCC, which please, colleagues, download and read. It's the best regional chapter in the IPCC. It's better than all the other regions, including North America and Europe. And it shows in this graph already attributable impacts of climate change in Africa in the purple and pink colors on the left. And you can see that over the vast majority of Africa, we can already attribute climate change impacts. And if we look on the right, what is to come, you can see the little gray line there, which shows which shows our temperature levels now and the increasing risks to biodiversity, to human health, and to food production from crops, livestock, and fisheries. We head into very dangerous territory with not much more warming. And yet we seem to want to stay addicted to fossil fuels as a country. I find it quite surprising. Despite the fact that we're the Saudi Arabia of renewable energy. In this next slide, I want to just show you how difficult it is to make projections of impacts on biodiversity per se. And this is work that I was involved with the IPCC, and it summarizes a vast number of studies using models where the biodiversity loss, the proportion of species going extinct, was plotted against global temperature rise. And we're obviously interested in where these risks really start to happen. And I think this is a very simple analysis which gives the likely and the very likely ranges just based on a quantile regression. But the proper way to model this, I believe, and we believe as a group, is using logistic regression. And we think that something like this is probably the better way to do it. And that gives us a better estimate of risk. And I'm going to show you, I just want to show you one quick example of an African species that appears to be struggling under climate change. It's this incredible quiver tree found along our west coast in Namibia and South Africa. And we've done some work on the species, and we find that its populations are currently dying in the hotter parts of where it's found. It has a massive geographic range from South Africa up into Namibia, north of the Brandberg, north of Windhoek. And you can see higher population mortality in the hot areas, and the population is doing well in the south. This is a classic fingerprint of climate change, which is showing in our biodiversity here in Africa. If we plot mortality against latitude, we see higher mortality in Namibia and lower mortality in South Africa. This species is shifting, and who knows how many other species are shifting. It's changing the face of biodiversity in Southern Africa. And it doesn't have to be this way. It's up to us. We can see through using matched photographs taken from decades ago, we can work out that the population growth rate in the north is declining and the population growth rate in the south is stable. So this is a species that is responding negatively to climate change. South Africa can hold it, but there are many species that we won't be able to hold here in South Africa. And on returning to our work done in the early 2000s, we now find many more populations have gone extinct of this magnificent species. How many others are doing the same thing? It's very expensive to do this kind of work, colleagues, and not many people are doing it. But when you go and look, this is the kind of thing you find. And we need to look more. I want to say one more thing, apart just from the direct effects of climate on biodiversity. I want to raise that we face significant risks from indirect effects. What do I mean? Many of you will have heard of plans by many groups funded to the tunes of hundreds of thousands to millions, tens of millions of dollars to plant trillions of trees around the world. And this, I think, is one of the biggest risks. If it's done inappropriately and in the wrong places with the wrong species, it can really cause major risks to biodiversity. We've written a paper about this called The Trouble with Trees. And I think we've had some positive effect and some impact on the world. These funders, I think, are now starting to take these concerns into account. It's difficult to get people to read papers from Africa, but at least other people have taken up the cudgels overseas from the work that we've done. So this message is getting out. But these are areas identified for afforestation by groups like the World Resources Institute. And you can see that these are areas that don't currently have forests, these orange areas, the grassy biomes. They don't have forests, but people want to plant forests here in order to store carbon and to suck carbon out of the atmosphere. Number one, it probably doesn't really work that well for a number of reasons. We can go into that in the questions and answers. But if we were to plant trees into all these systems that have been identified as high potential for afforestation, we would risk our endemic mammal richness, our carnivore richness, and our livelihoods in terms of cattle production. We would be condemning generations of Africans to looking after forests, not forests, plantations, usually of Australian eucalyptus, as opposed to pursuing their own livelihoods and using their own indigenous land use practices. This is a major risk. So this is not only about the impacts of climate change, it's the impacts of what I'm calling mal-mitigation. You've heard of maladaptation. This is mal-mitigation. And then finally, what's one of the biggest challenges we face? It's a lack of funding. It's a lack of support. Africa is responsible for fewer than 3% of global emissions. And you would predict that given that we are at the forefront of climate impacts, we're not responsible for most of the emissions. South Africa is trying harder to be more and more responsible. We get so little support from the international community. So look at funding for climate research on Africa versus the whole world. That's climate research going to the world. This is what comes to Africa. Is it? And this is from the good guys. Isn't it appalling? It's an astonishingly low number, given that we are not responsible for emissions. What's the result? Well, the result is that if you compare climate research funding as a proportion of general research funding, for the world, it's under 4%, probably close to 3%. But for Africa, it sometimes exceeds 10%. So that means that this lack of funding makes us have to invest more of our own meager resources in climate change research, even though we're not responsible for this problem. Colleagues, this is not fair. And, I think we need to stand up and say more about this imbalance and this complete and utter inequity. I'll show you one more graph, which is going to get your blood boiling. And that is of the top 10 countries receiving funding for climate research from 1990 to 2020. Most of them were not African. So the US, UK, Germany, Sweden, France, Netherlands, Norway, Italy are all getting more funding for climate research in Africa than the two top African countries, Kenya and South Africa. We're at the back of the queue, and we shouldn't be. What is going on? Okay. I just want to close with the risks, opportunities. We've got to, when it comes to biodiversity, we've got to think of the climate risks and climate solutions. Biodiversity is part of the solution, as I've shown you. What are the risks, though? The direct impacts, drought, heat, floods, wildfire, pests. But indirect impacts we've got to watch out for. Afforestation, malmitigation, the inappropriate land use, maybe risks due to increased food security is going to give us risks. All sorts of risks to our economies, border tariffs, emissions policies, carbon taxes, water use policies. And then what are the opportunities? Well, there's a whole lot. Carbon credits done in the right way, water savings, energy savings with additional human health, positive outcomes, savings in fertilizer, if we can use natural ecosystems better and slow down our intensive farming practices. And I think altogether diversification of energy systems, diversification of our use of natural ecosystems, and hopefully putting it all together, we can generate a much more sustainable, resilient Africa, which I think we should. Why should we follow the path of China, which you see the impacts of now with the flooding that's going on around Beijing, Hubei province, and all these other challenges. Anyway, colleagues, thanks for listening. I hope I've raised some ideas from a biodiversity perspective, and I look forward to your questions and discussion. Thank you.
Thank you so much, Prof. Those are some thought-provoking suggestions that you give. Scary stuff at the same time, yeah, Prof? The stuff that you're presenting is so scary and at the same time so painful, though that we still have a lot of doubting Thomases out there who do not believe that we are heading for stormy waters ahead. and that we here in Africa are more susceptible to impacts of climate change. That is even more worrying. There are a number of questions that we have on the chat, on the Q&A section. And perhaps let me also start off with a simple one for you, Prof. To what extent are our people aware of this issue that you're talking about, particularly the afforestation risk? Because people are talking about planting trees here and there and all of those, but to what extent are our people aware of these risks associated with that, if you know?
I think it's a topic that we need to raise awareness about much more. I think it is used by the funders to get cheap credits, which probably don't work anyway. And the reasons they don't work is that when you afforest, you actually cause local warming, because if you put a forest on top of a grassland, the forest is actually a darker color, and that can cause local warming, which can completely offset the carbon gains, which in any event take years to decades to accumulate. And the other adverse impacts are that you affect hydrology, the trees use more water, they take away grazing, and they basically remove livelihoods that were there before. So I think this is something that's got to be looked at with a huge amount of suspicion. But these companies are buying land or buying people to do this afforestation using invasive, sometimes alien trees from Australia, mainly eucalypts. It's really something that's got to be relooked at. It's happening over vast areas of our subcontinent. And I think it's something that we will deeply regret, years to decades from now. There's far better ways of doing things. And bottom line, it doesn't actually really help. It doesn't add to climate cooling. The negatives far outweigh any possible positives. So I would strongly advise you look in great detail, especially at national level. Be very, very careful to get scientific guidance on the net effects. I'm busy working with my group to look at, for example, some ideas around hybrid solar biomass energy systems, which would include some estimates of how changing that albedo, changing the color of a landscape by planting trees or removing trees, can add to direct forcing. So people are interested. We develop IP in that technology, and we're trying to look at all these angles. But we've got to be sharp, because the Northern Hemisphere is going to take advantage of us every single time.
Okay, excellent. Thanks for clarifying that. Continues to give me shivers. There's a question from Mike Lin who asks, how do you distinguish extinction of species due to climate change and extinction due to habitat loss or pollution and so forth?
Yeah, that's an excellent question. In fact, I've written a paper with Phil Hockey many years ago where we found a number of species that looked as though they were responding to climate change, but in fact, when we looked at it, it was something else. So this is called the problem of attribution. How do you attribute? And to do full attribution is very expensive, very difficult with the quiver trees, those I was talking about. It's taken us years to do the full attribution, and we're still busy with it. What one can do, though, is when you're looking at a preponderance of evidence where a lot of species that appear to be responding to drought or to warming, the accumulation of evidence is very suggestive. I think that's one way to get around it. But there are other ways, statistical ways, smarter and smarter with statistics. And we've got some of the world-leading statisticians in this area sitting, for example, at UCT, at an institution called SEEK. We're world leaders in this space, colleagues. We don't have to stand back for anybody else. But we struggle on very, very little funding. So we have a lot of scientific capacity. South Africa bats well above its position when it comes to knowledge on biodiversity, ecology, and climate change. We're, I think, in the top 20 nations, just in terms of raw scientific output, not even corrected for population funding or anything. Just in terms of raw scientific output, South Africa is in the top 20 countries on the production of scientific knowledge on these topics. So it's a massive strategic advantage, and we need to take more. We need to make more of it, and we're ready. Planting more.
Okay,
Sorry, will planting more trees help combat climate change? Not much. And there's a site you can go to called enroads, ENROADS.com. Go to that site, run the simulations, and see how little planting trees actually does. 0.1, 0.2 of a degree by the end of the century at best.
Okay, that's understandable. Prof, there is a question from Gerard Diedrichs. Let me find that question. Okay, let's start with one from Anonymous. To what extent does poverty and lack of energy contribute to climate change? Referring to factors common to Africa as opposed to Europe.
Poverty and lack of energy contribute to climate change. I would say very little. People who are poor and who lack energy will have a tiny climate change footprint, absolutely minuscule. The trick that we need to do here in Africa is to increase energy availability without increasing the carbon footprint, but also without increasing human health impacts, which are so often associated with fossil fuels, apart from all the other problems. So we've got the potential to do that. We can really improve livelihoods, create hundreds of thousands of jobs, and even become a local exporter of renewable energy technology into the rest of Southern Africa. We could lead the world in clean, renewable energy with our hydro, with our solar and our wind. We could become very wealthy, and that energy is relatively cheap. And once you have cheap energy, you open up a massive amount of opportunity. You can do some very, very interesting things like desalinate water and reduce your water limitations, as an example. So I think we've hardly looked at those scenarios because we are so keen to wed ourselves to the dark oil-soaked ideas of fossil fuels.
Okay, thanks for that response, Prof. You've got so many questions that are coming your way. The question that I wanted to direct to you earlier is from Gerard Diedrichs, who says, I still know and meet South African scientists who deny, what happened to Gerard now? Just hold on, Prof.
I've got it. Is that maybe a reflection of how poorly the scientific method and trust in sciences are addressed in our academic institutions?
In our academic institutions, yes.
I think it's just a reflection of ideology. It's very hard to change someone's mind once they've made it up. It's very, very difficult. I still see people debating whether the Earth is round or flat. But I would say that the scientists who deny climate change are few and far between and are deeply ideologically stuck in outdated science. Many of them are engineers, interestingly enough. But they're increasingly a lunatic fringe, I would say.
Okay, no, that's fine. There's another one from Anonymous. What are your views on nuclear power as an alternative to fossil fuels in an effort to combat climate change?
Well, I think what nuclear there is, I think Germany's made a mistake in bowing to green pressure to reduce nuclear energy because it's resulted in an increase in fossil fuel emissions. I don't think new nuclear is is a good way to go. It just takes so long to build. It's very intensive. It requires a massive investment. And to be honest, I think a lot of the nuclear scientists who we need are kind of retiring. They're moving out of the system. I think we've lost a lot of the technical capacity to even do nuclear safely. So, and it's going to take years, but we've got solar and wind right in front of us right now. We know how to do it. And all we do is we keep on funding. We send money to fund all these fossil fuel interests and nuclear interests. Just put the money into renewables. We'll get there very, very fast. So I don't know. I just think it's crazy. I think we are just missing a massive opportunity right in front of our noses.
Perhaps a follow-up question to that would be, people will always be talking about base load and arguing that perhaps solar and wind might not give you enough base load to be able to deal with. Yeah,
it's an absolute myth. Of course, you need some base load, but well, I can tell you one thing that would help South Africa enormously is just let's get 2 time zones. We put a time zone for the east of the country, Durban and Joburg, and another time zone 1 hour later for Cape Town. That alone would massively reduce the demand for baseload. But yeah, with smart grids, it's been shown you can massively reduce this dependence on baseload. I think it's a tired argument, and with new technology and with new ways of managing smart grids, we can move very, very fast beyond it. It's good for everybody. Energy becomes cheaper. It becomes democratized. We don't have energy sitting in one part of the country. We often hear it's unfair that Mpumalanga would lose its energy jobs, but how is it fair that all the energy jobs sit there in the first place? If you want to use that argument, I would switch the argument around and say, well, why all the energy jobs? Is it fair that they all sit in that part of the country? Isn't it more fair that it should be distributed? As long as you hold and allow those energy jobs to transition. So yeah, I think we've got to get a bit sharper on these arguments, to be honest.
Excellent. Thanks for that. There is a follow-up question from Nokulunga Memela. It's a follow-up question to the one earlier about distinguishing biodiversity loss due to climate change versus other factors. And she asks, what tools are used to measure biodiversity loss due to climate change?
That's a good question. I mean, there are a lot of tools we use, remote sensing from space, where we can look at vegetation cover and relate that somewhat to biodiversity changes. But also, incredible organizations like sandparks are always monitoring many of their species, and there are amazing databases. We've got some of the world leading databases. For example, the South African Bird Atlas program, Bird Atlas project, has been monitoring using citizen scientists bird richness since the 1980s, I think. So we can look at trends in one of these sensitive biodiversity indicators like birds from these data, and we do. And there are others. There are other biodiversity databases like this, many of which are get paltry funding, but are so enormously valuable to us. So if you look at the combination of the institutions that look after biodiversity, like sandparks and all the provincial biodiversity folks, and we look at the universities and all the work that they do, there is a wealth of resources. South Africa's got some of the best biodiversity databases. Look at the vegetation of South Africa. I don't think there's another country, a vegetation map and data as good as South Africa. It is absolutely. So yeah, we don't have to be ashamed about anything. We are world leaders in these areas.
Yeah, that's very true. Prof, there is Anonymous who wants to know as well. I'm sure based on some arguments that are currently happening all over the world in terms of where do people get products to generate renewable energy products like solar panels and all of those turbines and everything, we seem to forget the cradle to grave concept. How clean is renewable energy products really? That's from Anonymous.
Yeah, it's what's when you do the full, and you've got to do a full analysis, of course. You have to do the full life cycle analysis. But why haven't we done it on fossil fuels, including all the subsidies, all the hundreds of billions of dollars that have gone to subsidize the richest companies on the planet? Colleagues, really, let's do it fairly and talk about a full analysis of what is required in terms of mining, construction. You can't produce energy for a population as large as ours without some environmental cost. But what's the trade-off? What is the net trade-off? Nuclear versus fossils versus renewables. We've got to do this in an honest way. And there's way too much smoke and mirrors doing the rounds, So I would strongly support that. And let's get stuck in. But I would say it's very, very difficult to see how investment into renewables, which with more research could become even more green. Like, for example, if we produced renewables using renewable energy, you naturally reduce the carbon cost of those renewables. So then you get a virtuous cycle going. So South Africa, if it had a lot of renewable energy, produced the means of creating renewable energy, could export that into Europe, where, for example, solar panels that are produced on fossil energy take forever to recapture their carbon, their carbon cost. You could halve or reduce those carbon costs to a fraction. Anyway, so that would be my suggestion. I'm not an expert, but I think we need to throw everything that we can at this problem so that we have a very clear idea of the net costs, because we don't want to make
Perfect. Thanks, Prof. The hot topic, this issue. Ashley Mackenzie asks, what do you think of reported release of gases by the United States of America into the atmosphere to, in brackets, block the sun and therefore cool down the earth?
Look, if you look at what's happening in the Northern Hemisphere and the sort of climate chaos that you're getting, Hawaiian Island fire, the fires in Canada, these whole cities getting evacuated, Yellowknife, flooding in China, flooding in Europe. I fear a panic response, which would possibly include what's called solar radiation management, SRM, where aerosols are injected into the atmosphere in order to reflect the sun's rays and reduce incoming solar radiation. It doesn't affect CO2 and things like ocean acidification, but I'm not sure we have the climate modeling expertise to judge those risks. We have seen what happened after 9/11 when all the world's air fleet was grounded and the world warmed by a few points of a degree because of the effect of contrails. But, and also after volcanic eruptions like Pinatubo, we saw a few points of a degree cooling for several months because of those sulfate aerosols. But what does it do to the climate? And then who decides? How much do we cool the planet? Now you're really talking geoengineering. Who's got their finger on the temperature knob? like say in South Africa, we found that actually the best climate for South Africa would be, say, 5 degrees cooler. But sadly, it would cause the glaciation of North America. Well, we could offer them some compensation because our economy would do really well. We could maybe give them some adaptation funding to cope with glaciation. But we think that 5 degrees cooler is the best thing for us. So what I'm doing, I'm just putting the shoe on the other foot, right?
Yeah, interesting. Prof, there's so many questions that are still coming through, but unfortunately, we ran out of time. Perhaps this tells me that we still have a lot to talk about this topic on its own. But to finish off, perhaps there are 2 questions that I would want you to quickly respond to as we close this section. Liam Swanepo and Ketiwe Ngobo. Ketiwe says, the Department of Forestry, Fisheries and Environment is planning to plant millions of trees. Is there anyone who is looking after that program in terms of the implications that you spoke about earlier? That's one. Then Liam Swanepo says, small modular reactors seem to be overlooked when nuclear debate arises. These can be deployed much faster than large-scale nuclear and are based on newer, safer technology. Do you think these technologies should be looked at more openly, combined with renewables?
Absolutely, why not? If they're safe, if they don't increase other risks, but we don't have time. We're running out of time. So we need to do things that work now. We're literally we're approaching the brink of catastrophe. Sea level rise and impacts on ocean biodiversity. We are literally playing with fire now, and we don't have a lot of time to fine tune things. The world, if you look at what the IPCC says, we've got to reduce emissions hugely by 2030, 2040, and 2050. We can't hesitate. We've got to go hell for leather. So, yeah. But of course, every time you do an emergency response, you have a chance of making a mistake. So we must do the due diligence as well. Which we can. And all these concerns around cycle analysis, other effects, mining on people's livelihoods, yes, take them into account. And there are ways forward. We can do it. I'd be worried about planting a tree, 10 million trees in South Africa. Where? What species? For what purpose? Have you done the full life cycle analysis of that? What does it do to the are you afforesting or are you reforesting with indigenous species? If you're reforesting with indigenous species, great. That's superb. And if you're building local industry and getting people employed and getting people to appreciate their local ecosystems, fantastic. But if you're planting eucalyptus to grasslands, I think you got to look at yourself carefully and look at what you're doing.
Okay. No, thanks, Prof, for that. Thanks for responding to all those questions. I can tell you there's a lot of other questions that we could not even get to, but unfortunately, we don't have enough time. These questions will be sent to you. Obviously, the organizers might be able to get them through to the attendees somehow. Thank you so much, Prof. I would like to take this opportunity to thank you for the presentation and responding, but I would like to now hand over to Dr. Matawane to take us through the remaining portions of the program today. Thank you.
Thank you very much, Prof. Desmond, for really moderating this important and relevant discussion this morning. it is indeed evident that we are living in critical time where the impacts of climate change and biodiversity loss are becoming increasingly important and apparent. And by addressing some of these factors that you had discussed this morning, we can also safeguard our environment, but also create a more sustainable and resilient future for all of us. And of course, this will entail us working together to combat these challenges and preserve the beauty and the diversity of our country for future generations. On behalf of SECNASP, we'd like to thank you, Prof, for your willingness to participate in this webinar and to share your knowledge on this important topic. This will help us have a deep understanding of these pressing issues and take action where required in order for us to address them. Thank you for your thought-provoking presentation and for shedding some light on the interconnections between climate change and biodiversity. Really, your experience and passion has inspired all of us to take action and make a positive and meaningful difference. We'd like to thank all the participants who have joined us this morning. We had over 500 participants online. Your active engagement and thoughtful questions have enriched the discussions and has really helped us create a dynamic and informative session. Furthermore, we'd like to extend our gratitude to the organizing team for the thorough planning and seamless execution of this webinar. Your dedication and hard work has ensured the success of this event. And lastly, we would like to acknowledge the importance of collaboration and collective effort in addressing climate change and biodiversity risks. May we continue to work together and share knowledge and take concrete actions to mitigate these challenges and to protect our planet. Once again, thank you everyone for joining us, and enjoy the rest of your day.